Okay, so today we are going to be talking about solving one-step inequalities. So one-step inequalities, just like one-step equations, they should be really quick. So whatever the operation or whatever's happening to the variable, you just do the opposite operation to get the variable by itself, and you're done. It's just one step. The thing that we're really just looking at today is mostly we're still practicing, making sure we have the right circle on the graph. And remember, there's two types of circles. There's the open and the closed circle, right? Open is when we have the regular greater than or less than symbols. The closed circles when you have the greater than or equal to or less than or equal to circles. Okay? And we're also going to be practicing writing the interval notation. So interval notation, again, it's just basically the least number in the interval and the greatest number in the interval. So, and we use different kinds of closing punctuation, I guess is the term for it, to show whether it's just greater than or less than, or basically if it gets really close to but doesn't quite equal those numbers, or if they actually equal that number. So we're actually only going to really care about the number, because everything that you're going to do today is going to go off to either negative infinity or positive infinity. Okay? And since you can never equal infinity, you always use a parenthesis on infinities. Okay? For the actual number, because you're going to start at some number on the number line and then go off to one of the infinities. For the actual number, if there's an open circle that number, use a parenthesis. If there is a closed circle that number, you use a bracket. The bracket means that the interval includes that number. The parenthesis means it gets infinitely close to that number, but it doesn't quite equal it, right? Like if we're looking at all the numbers that are greater than 2, for example, 2 is not greater than 2, so it would not be included, but 2.00000000001, right, is greater than 2, so that would be included. So that's what the parenthesis means. Instead of making you write like an infinite amount of zeros, we use the parenthesis to show that it's basically 2, but not quite including 2. Okay? All right. So let's look at some examples of one-step inequalities and using our interval notation, all that kind of stuff. So looking at number 2, we have 7 plus p is less than or equal to negative 5. So we need to get the p by itself. So we look at the 7. It's adding, right? So since it's a positive 7, I'm going to minus 7 to each side. Okay? And that would give me p is less than or equal to negative 12. Okay? Not too tough, right? Let's do our graph on this now. So when we graph it, we locate the number that it's less than or equal to, which is negative 12, and we put a circle there. Now, depending on what kind of symbol we have, shows us what type of circle we're going to have, right? Since this is a less than or equal to, we're going to need to put a closed circle on there. Okay? Then, when we're talking about graphing the interval, we need to show what numbers are being represented by this interval. So it's all these numbers that are less than negative 12. So how you can tell if it's less than or greater than is the alligator. Right? It's got the alligator mouth, right? Alligator always eats the bigger number, right? So in this case, it's eating the negative 12, which means P is representing all those numbers that are less than negative 12. So the rule of thumb is if it eats the number, your arrow is going to go to the left. If it eats the variable, it goes to the right. So eats number, it goes left. Okay? If it eats the variable, eats variable, I'm not putting it right next to it so you can't get confused. Eats variable, it goes to the right. Okay? Eats variable, goes to the right. Eats number, goes to the left. Okay. Not too hard to remember, right? Then we need to do our interval notation. So it's always easiest to do interval notation by looking at the graph. So that's why the graphs are nice. So the graph will tell me basically what my least number and my greatest number is. So when I drew this arrow, the arrow means it keeps going that way, right? It keeps going that way forever. So like I said before, you're always going to have one of these infinities. If it keeps going to the left forever, that's the negative direction, right? So it's going to go left to negative infinity. Negative infinity is the absolute least number you can possibly ever have, right? You can't get less than negative infinity. It's like being infinitely in debt. Not something you want, right? So negative infinity would be my least number, okay? And you can do the little infinity sign, or you could write negative INF. That's what you're actually going to see on most of your quizzes eventually. But you guys do you, whatever makes sense to you. And then the greatest number is negative 12. So you put a comma and negative 12. So this is the interval that is being covered by this graph. Okay, now we need to do our closing punctuation, and this is what you guys usually get stuck on. Remember, infinities will always have a parenthesis because you can never actually equal infinity. So infinity should be easy. It's always a parenthesis. Okay? You really only have to look at the number to determine if it's a parenthesis or bracket, because this is going to tell me if I use a bracket or a parenthesis. So the closed circle means it does include the negative 12, and I show that by using a bracket. So if you have a closed circle at the number, you would put a bracket at the number. Infinity will always have a parenthesis, because again, parenthesis just means it gets infinitely close, but never quite equals. Bracket means it equals that number as well. Okay, so that's the difference between those two things. Okay, I want to do another one, but I want to show you one that actually is the big difference between inequalities and equations. So pretty much what we're doing with inequalities is the same thing that you do with equations. You do the opposite operation. There is one main difference about inequalities. Besides covering an interval, it's also kind of focusing on directionality, right? Like this little inequality symbol's giving me a direction. There is one thing that we can do in inequalities that will switch the direction. And anytime this happens, you should get a big warning that goes off in your head that tells you, oh, something needs to change here. And that is anytime you multiply or divide by a negative, it's going to flip the inequality sign. It's going to go the opposite direction. Okay? Because if you think about it, you would be moving the negative from one side to the others, which is actually going to change what this is really talking about. It's going to actually change and make things go the opposite directions. Okay? So for example, looking at, and I'm just going to rewrite this down here so you can see it better. Okay, so we have negative 8 times n. So to solve that, you would divide by negative 8, right? So we divide by negative 8 to both sides, and it's this number right here that's dividing to both sides that tells me that I'm going to have to switch the sign. Okay, so I get that warning. If this had been negative, the 24, that wouldn't matter at all. It's this number that's going from to both sides that will switch the sign. Okay, so when I divide by a negative, that inequality sign is going to change directions. It's now going to eat the left side, because when you notice 24 divided by negative 8, that's now a negative 3. Okay, so the negative has actually changed sides on the inequality. And so the inequality symbol will switch when the inequality, or when the negative sign switches sides as well. Okay? So let's go through and do all our things. So we know n is going to be, or negative 3 is greater than or equal to n. And again, it's eating the number here, right? Which means n is less than negative 3. So we're going to go up and we're going to put a circle. We're going to put it at negative 3. And it's an equal to, so it's going to be a closed circle. It's got that line underneath. And then since it's eating the number, that means the variable is all the numbers that are less than negative 3, right? So that means it's going to go to the left. And that would be your graph. Now, when we're reading the graph, it's going to the left forever, right? So least number is negative infinity. Greatest number is where the circle is, -3. Infinity always has a parenthesis, and then you see a closed circle there, so there'd be a bracket. Okay? I'm going to do one more just to kind of show you and emphasize the difference between this changing the sign and not having to change the sign. So let's look at like number 9, for example. I have 12v is less than -216. Okay? So 12 is multiplying with v, right? So I divide by 12. Now, -216 is negative, but is the number I'm dividing to each side negative? No. So the inequality sign will stay the same. It only flips if the number you're dividing to each side is negative. Okay? So v is still going to be less than whatever -216 is. -216 divided by 12 is -18. So -18. So that's one answer. Then I go up and I'm going to put a circle at -18. It's just a regular less than, so I'm going to put an open circle. And man, I picked all the less than. So this is going to go to the left as well because it's eating the number, right? And so the least number is -infinity. Greatest number is -18. Infinity always has a parenthesis, -18. We have an open circle at -18, which means it gets close to -18 but doesn't quite equal it. So we're going to put a parenthesis next to the -18 as well. Okay. If you have any questions or concerns, let your teachers know. We're here to help. You just got to let us know. And I'll see you guys out there.